In fact, we really want you to tell us what you're observing and what you think about what we're looking at. We're still learning even about what questions we still need to ask.
In response to global anticipation, all we received were blurry, HiRISE images, supposedly 30 kilometers per pixel, the same old comet catchphrase, and a tired lineup of missions tools and outdated visuals. It felt as if the secrets of 3i Atlas were simply not allowed to be revealed on NASA's November 19th live stream. Over an hour of talking, yet nothing truly said. The greater our expectations grew, the deeper the disappointment sank. It didn't resemble a briefing of discoveries at all, but rather a theoretical lecture crafted to lock our minds into one narrative. 3i Atlas is just a natural comet, nothing more. Take a close look at what follows. Then tell me, what do you make of these updates? Drop your thoughts in the comments. The details matter, and I want to hear which parts make you skeptical, which parts convince you, and which questions you think they still refuse to answer. Unhappily, the images we spent weeks, months waiting for turned out to be nothing more than a distant speck of light. A dot so faint that if you blink, you might miss it entirely. Another frame shows a broader glow, yet even that is so blurred and washed out that it becomes unacceptable for a machine this advanced, especially one delivering a staggering 30 kilometers per pixel. What we saw looked less like a cutting-edge capture and more like streetlights swallowed by heavy fog, the kind so thick you can even distinguish where the nucleus ends and the coma begins. And that struck public perception like a bolt of lightning. Think about it. In previous episodes, I've shown you a parade of breathtaking images taken by amateur astronomers around the world, across the Americas, Europe, and deep into Asia. Stunning frames where the bright nucleus pierced through a perfectly defined coma, and where both the forward-facing tail and the trailing ion tail were visible with remarkable clarity. If ground-based telescopes sitting over 200 million kilometers away can reveal such a structure, how is it that NASA's HiRISE, only 29 million kilometers from the target, cannot? Even if the instrument wasn't originally designed to track a small, fast-moving interstellar object like 3i Atlas, expectations were still far higher than this. Just 2 days after the live stream, NASA suddenly posted two sharp images comparing the intended purpose of HiRISE with the images HiRISE took of 3i Atlas. They said the left is what it was designed to take images of the Martian surface, which are bright, close, and stable. The right is what it was able to capture of the faint, distant, fast-moving comet 3i Atlas, along with two corresponding images. They claimed that 3i Atlas was too faint and too fast to get a clearer picture. The contradiction was almost laughable. We felt that this tweet reeked of defending the images they had released of 3i Atlas. How could they take such incredible pictures of Mars but not take a clearer picture of Atlas? Soon the posts flooded X. People weren't sure what they were seeing, but they knew something was wrong. Turns out we're not the only ones who have such thoughts about NASA's strange behavior. Some users even claim that Grok AI returns results that show the image has been edited. A typical example is the Astronomy Vibes page with over 29K followers. They had a tweet shortly after that with the content NASA says it's blurry because the comet is too faint and too fast. Funny how space cameras freeze Mars but can't catch 3i Atlas. And then they provided two images of their Grok AI results. Surprisingly, the result returned, "I conclude that yes, this photo appears to be digitally altered or artificially generated from Grok AI, and the same from Gemini AI. This indicates that the photo has been altered or created using Google AI. With what he provided, we feel very grateful for providing such interesting perspectives." Of course, AI only plays a part, but we cannot deny that NASA's actions are not really trying to tell us what they have been able to discover. For weeks, this line circulated everywhere. People waited, astronomers waited, the entire online community waited. The implication was clear: the October images would be the breakthrough, the moment when we finally saw 3i Atlas with unprecedented clarity. Yet what NASA released, allegedly 3 times better, looks no different from what Hubble captured back in July. No new details, no new structures, no improvement worthy of the wait or the technological hype. Just the same soft glow, the same indistinct blob, the same ambiguity, only now viewed through the lens of billions of dollars worth of hardware. So what does this prove with the opening statements? If this event were truly a long-awaited news briefing, then everyone expected it to start with what mattered most: fresh images, new measurements, and long-promised clarity. But no, right from the opening seconds, the screen did not show the long-anticipated data. Instead, we were met with carefully chosen words designed to diffuse speculation before new photographs appeared. Amit Kshatriya, NASA's Associate Administrator, took the stage first, and rather than unveiling updates, he delivered a definitive statement. 3i Atlas is not artificial. It is just a comet, its only unusual trait being its interstellar origin. A categorical denial delivered before presenting any evidence is by itself telling. It suggests a narrative being set in advance, a tightening of the frame through which the public is allowed to view the object. It signals an intention to control the tone, to soften expectations, and perhaps even to bury questions before they can be asked. It makes the audience feel that our genuine curiosity is being brushed aside. And this lands even harder because we have waited nearly 2 full months for this moment. Since October 3, when spacecrafts near Mars almost certainly captured the closest images of the third known interstellar visitor, excitement has grown day by day. We weren't asking for speculation. We were asking for evidence, clear, unambiguous images, data that speaks for itself. Yet what we received instead was emotional management, framing, tone setting. The live stream began not with discovery but with damage control long before anyone could react to the visuals that were supposed to follow. And so even before the first blurry HiRISE frame appeared, the audience had already been guided, limited, and subtly told what to think. It's a comet. Those 3 words echoed like a mantra, yet nothing NASA showed resembled a normal comet. It felt as though managing public reaction mattered more than presenting solid evidence. They insisted nothing was unusual but offered no convincing proof. The imbalance was glaring. It almost seemed as if any meaningful updates, if they exist, were intentionally withheld. And when uncertainty grows and key questions are sidestepped, people inevitably wonder what's the truth.
I expect the HiRISE image to show a fuzzy ball of light like the Hubble image did, but I hope to be surprised. And I must say that I was not surprised.
But the effect was chilling. Time dragged on. Over 60 minutes, the live stream felt like a storytelling session rather than a high-priority briefing. Nearly 40 days of analysis, some 18,000 minutes of administrative and scientific work were compressed into a talk that carried none of the urgency or insight the object deserved. For the public, for professional astronomers eagerly waiting to dive deeper into this interstellar visitor, it felt like a betrayal of expectation, a missed opportunity to finally illuminate one of the most extraordinary objects humanity has observed. Instead of a breakthrough, we got repetition, rationalization, and avoidance. And as the questions multiply, the sense of mystery, and perhaps even suspicion, only grows stronger. They explained in vivid detail what a natural comet is, how it is structured, how it behaves, and how it interacts with its environment. The descriptions were clear, precise, almost textbook perfect. Yet when it came to 3I Atlas, everything we have observed tells a different story. Its brightness, its gas emissions, the chemical compounds detected, all of these behaviors contradict what we have ever seen in ordinary comets. If NASA insists on labeling 3I Atlas as just a comet, they bear the responsibility to prove it. Every claim should be supported with clear evidence, and each argument laid out meticulously step by step. A blanket statement is not enough. When an object so fundamentally defies expectations, rigorous justification is essential. Without it, the public and the scientific community are left with more questions than answers, and the extraordinary nature of this interstellar visitor remains shrouded in doubt. NASA did in fact release a high-resolution detailed image, but not of 3I Atlas itself. Instead, it came from the chemical emissions of nearby planets captured on September 28th by an instrument aboard NASA's MAVEN spacecraft 2 days before the comet's official breakdown. You might think this would be the turning point of the live stream, the moment when we finally glimpse something substantial. Think again. Even in these detailed analyses, the most suggestive hints were rushed past as if deliberately glossed over. The ultraviolet spectral image shows 3 streams of hydrogen gas emanating in order from left to right from 3I Atlas, Mars, and the Sun. But even this doesn't reveal the full picture, and certainly not any clear form of the comet itself. They went on to list 20 mission teams working in coordination, proudly declaring that all the insights presented were thanks to the combined power of modern scientific instruments distributed across these 20 missions. Yet these words felt more like a convoluted justification than an explanation of results. Achievements were presented, but so were reasons to explain away the gaps, leaving the audience wondering what was actually being withheld. They highlighted the ratios of carbon to water, nickel to iron, and even cyanide, all strange chemical signatures remarkable enough to rival the experiments being designed and launched into the stars themselves. They admitted the oddity, but still insisted it was normal, attributing it quickly to 3I Atlas's unusual origin, and then swiftly pivoted back to stories of a regular comet. The result was a strange mixture, undeniable hints of the extraordinary wrapped in the language of the mundane, leaving viewers suspended between curiosity and frustration. You see, we had every reason to be excited for NASA's long-awaited briefing. Notifications for the live stream had been circulating everywhere ever since the moment it was announced. After all, the list of anomalies highlighted by Professor Avi Loeb was simply too long to ignore. 12 major discrepancies that refuse to fit into any conventional comet model. From the object's bizarre orbital inclination relative to the ecliptic plane to its colossal size exceeding the previous 2 interstellar objects by thousands or even millions of times, to the uniquely shaped antitails to the metallic nickel blends that resemble refined alloys rather than primitive cosmic dust, and the list goes on. Naturally, the public's suspicion had grown enormous, and NASA, as the world's leading authority, was expected to deliver sharp, transparent explanations. If 3I Atlas were truly just an ordinary harmless comet, then each anomaly should be addressed clearly, point by point. That was the hope. That was the expectation. But what did we actually receive? A single confident statement, yes, it's a comet. And everything else full of uncertainty, full of gaps, full of we don't know yet, even during the Q&A session meant to clarify the hardest questions. When pressed about the nucleus size, they said it remained undetermined. When asked about the shape, they admitted it could not be identified due to the dust cover and reflected sunlight. When questioned about its origin, they described it as too complex to trace because the galaxy is vast and not straightforward. So if the size is unknown, the shape is unknown, the origin is unclear, on what basis are we expected to accept that this object is definitively a comet? The answers were so roundabout that many viewers probably couldn't tell whether the NASA representatives had actually addressed the question or elegantly dodged it. What they did emphasize again and again was simply that the object showed no signs of technology. But that's not the same as explaining why it is a comet. It's a conclusion without the path, an answer without the reasoning, a result without the proof. And if a problem is presented with only an answer and no demonstration, no transparent logic, no step-by-step justification, how can anyone confidently believe that the answer is correct, especially when the problem itself is filled with contradictions? Indeed, watching the live stream from start to finish felt like being carried along a carefully curated emotional arcone that subtly guided us toward accepting the interstellar comet narrative as if it were the only reasonable path. Not because the data was lacking, but rather because the full dataset simply wasn't shown. Again and again, the speakers reassured us that more time was needed, more calibration, more processing. And so what was advertised as an official results briefing slowly revealed itself to be something much gentler, a cautious, scientific fireside chat wrapped in soft language and deliberate restraint. And yet, despite all the frustration, despite all the unanswered questions, we should still acknowledge the foundation we stand on. Modern science has been polished, challenged, refined, and strengthened over centuries. Its methods have endured storms far greater than this. Time, as always, is our most valuable instrument. Time reveals. Time corrects. Time clarifies the mysteries we cannot yet decipher. And time is exactly what we still have. There is nearly 1 month left before 3I Atlas makes its closest approach to Earth. When that moment arrives, the instruments built for precision, the ones waiting in silence for the ideal geometry, will finally have their chance to capture the breathtaking, decisive images we've been longing for. The kind that leaves no room for doubt, the kind that redefines our understanding of the cosmos. Until then, let's stay curious together. Let's keep building a community of people who love the night sky, who look up not just for answers, but for wonder. You are always welcome here in this channel. It is wide enough for all of us.